So what we just did was we performed long division with two polynomials instead of two numbers. And for any two polynomials f and g, there are unique polynomials q and r such that f of x is equal to g of x times q of x plus r of x, where r of x will always have a degree less than g of x. What in the world does that mean? Well, let me show you. Let me illustrate it with the work that we did in the last example here. So we divided these two things and got this as our quotient. So what this is our p of x, or our f of x, I should say. And we divided by g of x. And that was equal to our quotient, q of x, plus our remainder divided by g of x. If I simply multiply through, if I take this whole thing, multiply both sides by x squared plus x plus 2, what I'm left with is my original polynomial. I'm left with my original polynomial, 2x to the fourth, plus 4x cubed plus 3x squared, plus 2x minus 7, equal to q of x times g of x plus this remainder. That's my r of x. And imagine for a second that if the remainder was 0, I would have, in essence, taken that and written it as the product of two factors. In other words, I would have factored it. So notice that the thing I was dividing by, the x squared, that right there, my remainder has a degree that's less than that. Its degree is simply 1. So let's move forward, find the remainder when f of x is this fourth degree polynomial, and I'm dividing by g of x, which is a linear polynomial. Think for a minute. What kind of remainder should we get? It has to be of less degree than what I'm dividing by. So you should be expecting a constant, a number, a numeric value as the remainder. And we could do long division. Okay, we could do 2x to the fourth, blah, 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 and x plus 3 out here, and go through our long division. But you know what, guys? I'm going to show you another method that works as long as I'm dividing by x plus a number, or x minus a number. We're going to do what's called synthetic division. And it's an algorithmic approach to doing this. What I'm going to do is I'm going to take the coefficients from all the terms in what I'm dividing. So I'm dividing this fourth degree polynomial. I start with the leading coefficient, 2. Then I take the coefficient from x cubed, and then x squared, and then x, and then the constant. And I write those down in order, and I put them in this little box. This is an organizational tool, this box is. You might see this written other ways. This is how I choose to do it. So if I was missing a term, again, just like with long division, if that term wouldn't have been there, I would need to have a 0 to hold its place. Every place must be represented here. And now what we're going to do is we're going to take the value that would make this 0. So I'm going to put -3 out here. This is a 0 to that g of x. And here's the algorithm that we'll use. We're going to multiply outside and add inside. But first I have to get something outside. I take the leading coefficient and drop it down. Now I'm going to multiply these together. -3 times 2 is -6. And I'm going to add inside the box. Then I multiply again. And then I'm going to add. And then I'm multiplying again, so now it's -96. And then I'm going to add. So this is negative 82. I'm going to multiply again. And now finally I add, getting 251. That is my remainder. Another way that I could write this would be this is equal to, using what we had on the previous slide, x plus 3 times my quotient. These are now coefficients of what we call a depressed polynomial. This started out as x to the 4th. Well, this is now x cubed. I'm dividing out an x, remember. So this is times 2x cubed minus 13x squared plus 32x minus 82 plus 251. Now, this is also called synthetic substitution, because if you actually take this number and find f of that number, if I found f of negative 3, guess what I get? We get 251. It accomplishes the same thing as plugging in negative 3 for all those x's and crunching the numbers. So it's an algorithm that allows us to plug values into functions. So, and that's what the remainder theorem says. Given f of x is this polynomial and a real number p, then the remainder when f of x is divided by x minus p will be f of p. Cool. We see that in the previous example. And to note, p is the value that makes the divisor 0. It's a value that makes that thing I'm dividing by 0. It's the thing that I would put in here. If we had x plus 2, p is negative 2, and to find the remainder, I'd take that, plug it into the polynomial. I can either do a direct substitution, where I plug it in for all the x's, or I could do this synthetic substitution thing. So, let's take this a step further. We have the remainder theorem, now we have the factor theorem. A polynomial, f of x, has a factor, x minus p, where p is in the real numbers, if and only if, that's what the double f means, f of p equals 0. So when I substitute p into the polynomial, I better get 0. It better be a 0 of that polynomial. And what that means is that if I do synthetic division and I get a remainder of 0, that thing I divided by, that binomial that I'm dividing by, or that polynomial I'm dividing by, is a factor. Big, cool, awesome theorem right here. Let's put it into practice. Show that x minus 2 is a factor of this. Well, you know what? We haven't really discussed how to factor cubes. Sometimes you can do it quickly, sometimes you can't. I'm just going to show that it's a factor. In other words, I need to show that when I divide by x minus 2, the remainder is 0. I have no remainder. That's what it means to factor something. Get that thing written as something times something with nothing left over. So, 2 ways to do it. We could do long division and put it here, but since this is x minus something or x plus something, I'm going to go ahead and use synthetic division. 2, 13, 1, negative 70. And I put 2 outside here. 2 is the value, it's the 0 that I'm claiming works. I'm claiming that 2 is a 0, is a root of this polynomial. And if it is, that means x minus 2 is a factor. So how do we do this? We drop the 2 down. Now we multiply outside and add inside. And then I do 2 times 27, and I get, what's that, 54? We add inside and, oh shoot, I don't get 0 as a remainder. What does that mean? Well, it means I made a mistake, people. It means that I'm supposed to show that this is a factor. I better get 0 when I'm done. So I got to go back and double check my work. I'm going to go all the way back and start over. This is going to happen sometimes, and it's okay for it to happen. It's a way to check what you're doing. You need to get 0 at the end. So we have 4. Oh, here's my mistake. This is 17, not 13. Got to remember to add. 2 times 17 is, oh, what would that be? 34. Add 1, we get 35. Now multiply by 2, we get 70. And la-ha! Remainder 0. So what does this mean? Well, it means that f of x is equal to x minus 2 times this new depressed polynomial. So times 2x squared, remember the degree of x drops 1, was x cubed, now it's x squared, plus 17x plus 35. If you don't believe it, go ahead and expand. You will get our f of x. Crazy, cool stuff, guys. Now, when f of x, here's f of x, is divided by x minus 2, the remainder is 1. So x minus 2 isn't a factor, but it has a remainder of 1. I want to find a. Right there. Oh, boy. I'm going to use synthetic division to help. We're going to go 1. Coefficient of x squared is negative 2. And the coefficient of x is a, and then 11. What goes outside here? Pause the video, write down the number. You better have written down 2. Now, I want you to try and do the synthetic division. I want you to try and do the synthetic substitution. See if you can get the answer knowing that the remainder, when you're all done, needs to be 1. Okay, so let's start reasoning through this. Bring the 1 down. Multiply. That's 0. 2 times 0 is 0. Here's a. We multiply here. We get 2a. Okay, what do we do with these two things again? That's right, we add. So 2a plus 11 needs to be 1. We should have been able to also reason out that this stuff, in order for this 1 to be there, we would need this value, 2a, to be equal to negative 10, which is what we get when we subtract 11 from both sides. So a needs to be negative 5. There we go. You're not always going to know all the coefficients. You're given some information. You need to go through this process and figure out what the missing coefficients are. In the next video, we're going to look at, well, okay, cool, we did this division by x minus p, but what if there's a coefficient on x? Can we still use synthetic division, or do we have to go and deal with long division again, which is okay, but it's a little bit longer? So, next video, that's what you have to look forward to. Enjoy, have a wonderful day.